All right, thanks, Jeffrey. We have a bunch of questions. I think Florian had one and is here in the panelists.
Yeah. Hey, Jeff. Really enjoyed the talk. Sorry, one second. Sorry about that. Given that you said that RSS is invariant equivalent to strict serializability, is there an advantage of still using strict serializability? Are there applications that care about more strict real-time constraints, or is strict serializability simply too strong and outdated and one should move to RSS instead?
Yeah, that is a great question. So I think there are maybe two things there. One is, so something I didn't have time to talk about in the talk is that there is some added complexity for RSS compared to strict serializability for applications that are using multiple backend services, like interacting with maybe a database and a queue service or something like that. So that could be a consideration where maybe strict serializability makes sense over RSS. But I think for applications, many applications that are sort of just interacting maybe with one backend service, RSS is providing, I think, a very nice alternative to strict serializability, and sort of is following your intuition that maybe strict serializability is too strong for many of those applications.
Marcos, you have a question?
Yes, and another question with respect to invariant equivalence. I'm just wondering if your definition of invariant allows predicates that cut across the state of different processes, and whether your result would hold for such invariants as well for the equivalence to strict serializability.
Yeah, so that so again, I didn't have much time to talk about the details in the talk, but this is sort of more clearly defined in the paper. The invariants are cutting across sort of, it's basically the union of the states of the application processes. So this result that we have sort of holds for those kind of invariants as well.
Also, you're saying that invariant could have, for example, variable X of process P1 is equal to variable Y of process P2. And if that's true for, let's say, strict serializability, will be true for you as well?
Yeah, I guess the way to think about it is like, if it would be true for all executions of the application while using a strictly serializable database, then it will also be true for sort of all executions of the same application running using a RSS service.
Okay, now the reason I ask is because your proof is based on projecting on the state of each process separately. And so I have to dig deeper into this to make sure I understand this. But that's why I had that question in my mind. But let me look at this more carefully, and then I'll get back to you by email or something. Thank you.
Okay, yeah, I'd love to chat further offline. Then yeah, thank you.
Other questions? Let's see. So I guess I had one question, which is in the systems you modified, you talked about how you could save round trips and so on. But I am wondering, do the sizes of messages or other things go up with this? Like, what are the trade-offs you should consider as a system designer when deciding whether to use this?
Yeah, that's a great question. So so if we take the spanner RSS variant to sort of make it concrete, then there definitely are some additional messages, because we've essentially introduced a fast path where that allows us to sort of get this lower latency, but then there has to be a fallback onto a slow path. And so you're introducing additional messages there potentially, although they're only, so yeah, I guess depending on the application, that may be acceptable or not. In our case, in the Spanner RSS specifically, the extra slow path messages are sort of on this order, like the number is on the order of the number of keys in a transaction. And basically it depends on how many conflicts you could possibly, conflicting transactions.
So does that mean the tail latency can go up as well? I guess if you touch a lot of keys.
So it shouldn't go up, at least compared to Spanner, because basically these slow messages are just coming at exactly the same time Spanner would have unblocked itself. So you're sort of getting no worse than, I guess, if you're sort of, those extra messages are somehow introducing some additional latency in your system, then I guess that might be the case. But in the evaluation that we tested, we didn't see that effect.
Makes sense, yeah.
Just because wide area latency was sort of the dominant thing.
That was the dominant thing. Yeah, that makes sense, yeah. Got it. Cool, any other questions from the audience? Okay, so I guess we can come back at the panel at the end. And yeah, I see your paper also has artifact available, which is great if people want to check out the code.
Yeah.
All right. So yeah, thanks for the presentation.
Thank you.
So for our third paper.
Thank you very much, Jeffrey. So as a reminder, again, if you have any questions, please ask in the Slack. So Inho, it sounds like you have a question. And I would just, before we start, thank Jeffrey for being up. And if I'm not mistaken, at nearly 1 a.m. So, you know, go easy on him. It's late. Inho, go ahead.
Yeah, sure. Hello, I'm Ino from NUS. Thanks for the clear talk, Jeffrey. So my question is, looks like RSS is kind of a better model to apply when it's possible compared to the strict serializability, because it has some performance advantage. So I wonder if there is some applications that cannot apply the RSS, but only can apply the strict serializability. So yeah, could you answer to this question?
Yeah. So I'd say, so one thing I didn't have a ton of, didn't have time really to talk about in the 10-minute video is that there is some added complexity when you're using, or when you have an application that is using potentially multiple backend services, say that guarantee RSS. So that could be like a database maybe and a queue service, like that would be a simple example. In that case, there is some sort of added complexity to use RSS for both of those services and sort of compose them and ensure that the composition is sort of RSS across both of those services, whereas it's simpler in strict serializability. And so that might be a case where you might want to prefer strict serializability. But I'd say for an application, a web application that is that is sort of only interacting with one backend service, I think, yeah, our paper is trying to make the case that maybe we should be looking at RSS as a better alternative.
Got it. Yeah, thanks.
Thanks.
We have another question. Let me promote him as panelist. Abhilash, you can if you can turn on your video, introduce yourself and ask the question, that'd be great. Thank you.
Hi, I'm Abhilash from IIT Delhi. Sorry, I won't be able to turn on my video right now. But I think I missed something key here. Why was it okay to, since read of X finished before starting read of Y, why was it okay to flip them in RSS?
Yeah, are you referring to the sort of shifting example that I was showing in the slides?
Yes, yes.
So while a write is ongoing, basically, so RSS kind of relaxes the real-time constraints that strict serializability imposes on reads, right? So Strict serializability says like once a read returns x equals 1, then all future reads have to return, x equals 1 or y equals 1 in the example. RSS relaxes that constraint so that it's just causally later reads. So because that's being executed by a different process, and those processes aren't communicating by any like message passing or anything like that, it is okay for that second read R2 to return basically y equals 0 in the example.
I see. So if it was in the same process, then we definitely can't do that.
Yes, exactly.
Okay, got it. Thanks.
Yeah.
Okay, so doesn't look like we have another question just yet, so I'll follow up on the last question. So I remember in the spanner example, the motivating example for strict consistency, strict serializability is I read x equals 2, I call my friend, I say, hey, x is now 2, and my friend still sees x equals 1.
Yeah.
So there's an Autobahn communication, and I'm curious whether or not how do you deal with this example in RSS?
Yeah, so that's a great question. So that's really what our sort of choice of a select set or subset of real-time guarantees are sort of aiming to address, is this kind of out-of-band communication, and to minimize what we call in the paper like these user visible anomalies, like the one you just described. So I think our paper is not trying to say that like those anomalies don't matter, but I think so there's some previous work with Facebook sort of measuring basically potential anomalies returned by their eventually consistent system, and that work shows that potential anomalies that are not even like actually observed are pretty rare, so like 6 in a million operations. So I think our work is trying to maybe show that for something that is likely extremely rare in practice, at least in these sort of large web applications, it might be worth it in some cases to be looking at designs that get you better performance. Is sort of how I would think about it.
I guess let me again abuse my privilege of being session chair and not let you go to bed just yet. But my second question was kind of related, which is, are there any invariants that you can't maintain when they're expressed in the application? So obviously in the paper, I assume that you have a much more detailed definition of what invariant is, but I'm curious if you could, broadly speaking, say a little bit more about what you define as an invariant.
Definitely, yeah. So it's definitely defined more precisely in the paper, but so we are able to sort of handle invariants. It's not like scoped in any way to like individual process states that are executing. So it can be invariants that are expressed as like predicates across the sort of combined states of all the processes in the application. I think a key assumption, though, that again I didn't really have time to go into in the presentation, is that we're assuming that the application doesn't make any assumptions about how synchronized its clock is. So it might be able to set sort of local timers, but it's not making any assumptions about how close that clock is or that timer is to the timer at another process within the application. So with that assumption, basically, then we're able to that allows you really to do the shifting and the manipulation that we showed in the slide, and do this sort of transformation, and then that sort of enables the proof result. So that excludes, I guess, some class of invariants.
You have a last question, Jorian. If you can introduce yourself and ask it, that'd be great.
I think you're still muted.
Oh, okay. Can you hear me?
Yeah,
Yes.
yeah.
If I might be misinterpreting the talk, but I was thinking that if there might be an assumption that when there are multiple processes of the application, there are little dependency between each application, so that the cost, so that you can like to reorder the read-only transaction early in the total time order. But I wonder that in order to determine to know that there is no dependency, will there be much communication overhead between each process? So if there is, will this affect the scalability? If not, how do you achieve this? Thank you.
Yeah, that's a good question. And I think, so I think we think about that as, so there's some existing work on, especially within these sort of big web applications that are deployed across like multiple data centers, say at like Facebook or something. There are these like context propagation frameworks already in use that are, I think, now often used for like distributed debugging, but we imagine that they could be used to sort of forward around some little token or something to sort of properly track the causality that's necessary for RSS. So I think we believe that communication overhead should be relatively small. It should be, maybe just a timestamp or something like that, a 64-bit timestamp. But I'll admit that I think this is definitely an area for future exploration on sort of fleshing out how to do this well and do this properly. Yeah.
Thank you.
Thanks.
All right, well, thank you very much. This is going to conclude the questions for this particular session. You're so much ready to go to sleep, Jeffrey. Please stick around for the panel afterwards. But now we're going to move on to the final paper of this session, which is also going to be on transactions, called Caracal, Contention Management